This video is going to explain how to simplify radicals if the radicand, or the number under the radical, is not a perfect square or perfect cube. So this one, number 1, remember this is a square root. Doesn't have a number there, so it's understood to be a 2. It's a square root. What you want to do is you want to try to figure out how many pairs that you have so that you can bring those out of the square root. So in other words, let's think of something else really quickly. Let's say I had the square root of 5 times 5. Or say I had the square root of 25. The square root of 25 is 5, and that's because 5 times 5 is 25. This is a square root, so you're looking for a pair of something so that you could bring it out. If you had this cube root, let's say of 8, you're looking for something times itself 3 times. So this would be 2 times 2 times 2 is 8, and since there are 3 2's, you could bring that out as a 2. So your root, or your index, is telling you the group size. So if you have a pair for a square root, you can bring the pair out of the radical. In the cube root, you have to have a group of size 3. So you'd have to have 3 of the same factor in order to bring it out of the radical. This is true for any index. So it could be the 4th root. That means you would be looking for a group of size 4. Or a 5th root. You'd be looking for a group of size 5, etc. So what you want to do is you want to use a factor tree. So we're going to put down the number that's under the radical. The radicand in this case is 200, and we're going to split it up. We know that 200 is the same as 20 times 10. And you can use any two numbers. You could have done 2 and 100, whatever you see that works. So 20 will break down into 4 times 5. 4 breaks down into 2 times 2. 10 breaks down into 5 times 2. So I've now gotten all prime numbers on the ends of my branches. And so what I want to do now is look for groups of 2. So I have 2 2's, so that's one group of 2. I also have 2 5's, so that's another group of 2. And then notice that I have this leftover 2. It does not pair up with anything. So that's going to stay under the radical. Any pairs will come out. So we have a 2 that's coming out, a 5 that's coming out, and you multiply them together, and then the 1 2 by itself that stays under the radical. You simply multiply the 2 and the 5 to get 10. Whoops, and that's not a 5, it's supposed to be a 2. And you get 10 square root of 2. So that is simplified. And that's going to be the process you use every time. So let's look at number 2. In number 2, first notice that we have a negative under the radical. So that's going to come out as an I. So don't forget that part. And now we want to simplify the 98. So we'll write down 98. 98 divided by 2 is 49. 49 is 7 times 7. And so that's all prime numbers. So our pair, we have a pair of 7's, so that's going to come out. And then we have a leftover 2, that's going to stay under. So we'll have a 7 out front with the I, and the 2 stays under the radical. So we'll have 7i times the square root of 2. Okay, let's look at number 3. So number 3, we've got negative square root of 150. So this will not have an I because the negative is outside the radical. So we can just bring the negative down. And then we want to simplify the 150. So we're going to do a factor tree. We could do 10 times 15. 10 is 2 times 5. 15 is 5 times 3. We've got all prime numbers at the ends. We can see that we have a pair of 5s, so that will come out. And then we have a 2 left over and a 3 left over, so those are going to stay under. So we're going to bring the 5 out, and the 2 and the 3 stay under, so we will multiply those together, and we'll get -5 times the square root of 6. Okay, so the same idea can be used for variables. So what we're doing here, we've got a square root. This means x times x times x. So any pair of x's would come out, and whatever's not a pair would stay under the radical. So one x would come out, and one x would stay under. But it's not realistic to think that you're going to write every variable down. Like, for example, if you had x to the 82nd power, you're not going to write down 82 x's to figure out how many pairs there are. Instead, you're going to use the idea that we talked about in the last video about dividing. So the rule is you divide, so let's say we have the square root of x cubed. That's the same as x to the 3/2. You divide the numbers, so you're going to divide the 2 into the 3. So you want to see how many times does 2 go into 3. Well, 2 goes into 3 once, then you multiply. 1 times 2 is 2. You subtract and you get your remainder. The number on the top is the exponent that comes out. The remainder is the exponent that stays under. So a 1 exponent comes out, so that's where you're getting this x. And then a 1 exponent stays under, that's where you're getting that x. So you're going to divide, and your leftovers will be, or your remainder, will be under the radical. So let's look at number 5. So first thing, we've got a bunch of negatives. This negative out front is going to come down as a negative. It's a square root, so this negative is going to come out as an I. Okay, so that's first thing, take care of that. The square root of 25, that's going to be just 5. Okay, so I'm going to squeeze that between the I and the negative, so we'll have 5i. And now we want to simplify the variables. So the understood exponent is 2. So we need to divide each, I said exponent. The understood root or index is 2. We want to divide each exponent by the root to see what we get. So for x, I'm seeing how many times does 2 go into 6. 2 goes into 6 3 times. 3 times 2 is 6. The remainder is 0. That means x cubed comes out, and x to the 0 stays under. X to the 0 means you don't have an x under. So it's going to be x cubed on the outside. Now we're going to do the same thing for the y's. So for the y's, I have 2 going into 9. Well, 2 goes into 9 4 times. 4 times 2 is 8. I subtract and I get a remainder of 1. So 4 is the exponent that comes out. The remainder stays in. So that means I have y to the 4th coming out and a y to the 1st staying under. So here is my answer. All right, let's look at number 6. Again, we've got a negative underneath the radical, so that's going to come out as an I. So don't forget that this is coming out as an I. We've got 63. That's not a perfect square, so I'm going to have to break it down. So this is 9 times 7. 9 is 3 times 3. pair of 3's left over 7. So 3 comes out, 7 stays underneath. So I've taken care of the 63. Now I'm going to do each variable. So for the x, I want to see how many times 2 goes into 9. So this is for x. 2 goes into 9. We just did this 4 times. The remainder is 1. So that means x to the 4th comes out and x to the 1st stays under. And now we have y's. So how many times does 2 go into 15? 7. 7 times 2 is 14. Subtract and get 1 left over. Whoops. So 7 is out, 1 is in. So that means y to the 7th and y to the 1st stays in or under. And that would be the simplification of that. Okay, number 7. Now we have a cube root. So notice the index has changed. So now we're looking for groups of size 3. So the cube root of a -8. Remember that this is not an I. The I comes from a square root. So the cube root of -8 is -2. And then we want to divide. So for x, we're going to see 3 goes into 7 how many times? So that would be 2. 2 times 3 is 6. The remainder is 1. So exponent of 2 comes out. The exponent of 1 stays under. So we'll have an x squared out here and a plain x or x to the 1st underneath. And remember that it's a cube root, so don't forget to write your index. And now we have the y's. So for y, we're looking at 3 into 22. 3 goes into 22 7 times. 7 times 3 is 21. Subtract and get 1 as your remainder. So we have 7 coming out, 1 staying in. So that means y to the 7th on the outside and y to the 1st under the radical. And that would be it. Okay, number 8. So we have the cube root of 250. So I don't think 250 is a perfect cube. So we're going to do a factor tree. So that would be 25 times 10. 25 is 5 times 5. 10 is 5 times 2. We can see that we do have a group of 3. Remember, that's what we're looking for here, is a group of 3 because it's a cube root. And then we have a leftover 2. So a 5 is going to be on the outside, and a 2 is going to be left on the inside. And then we're going to do the same thing with the variables. So we have m to the 21st power. So for m, we're going to be seeing how many times can 3 go into 21. And it actually goes in evenly, 7 times. So we'll have m to the 7th on the outside. And then we have n squared. Notice that the exponent here, the 2, is smaller than the root. That means you're not going to have a group of size 3. So anytime your exponent is smaller than the index, that's just going to stay put. So that's going to be it. So just to keep everything together better, I'm going to write it again. And that's it. Okay, so if you haven't tried any of these on your own yet, I would suggest pausing, trying these, and then just checking after to see if you got it right. So for number 9, I'm not sure if 343 is a perfect cube or not, so I'm just going to start trying to make a factor tree. So let's see, 343 is divisible by 7. So that's 7 and 49. 49 is 7 times 7. Those are all prime. And you'll see that we have a group of 3 7s. And we have nothing left over. So that means 343 is a perfect cube, and it's just going to come out as 7. Now I want to try the x and the y to simplify. So for x, I've got the root or index of 3 going into the exponent of 5. 3 goes into 5 once. I subtract and I get a remainder of 2. So that means a 1 is coming out and a 2 is staying under. So it's going to be x to the first on the outside, and x squared is the leftover on the inside. And I'm going to do the same thing with the y. Y is 3 into 4. 3 goes into 4 once. Here I'll have a remainder of 1. So 1 comes out, 1 stays under or in. So it's going to be a y and a y. And that would be it. All right, the last example here. We have a 7th root of 3a to the 35th, b to the 43rd, and c to the 9th. So the coefficient of 3, there's no way I'm going to be able to break that down. First of all, because it's prime, but second of all, even if it wasn't, it's such a small number, it's not going to have a group of 7. So 3 is just done. That's going to stay under the radical. So now it's just a matter of trying to simplify the variables. So how many times does 7 go into 35? That's for the a. It goes in 5 times, and it goes in evenly and no remainder. So a is coming out as a to the 5th. So 5 come out, and none are left to stay in. So there will be no a under the radical. For b, we have 7 going into 43. I believe that's a 6, right? So 7 times 6 is 42. So you subtract and you get 1. So 6 come out, 1 stays in. So that's going to be a b to the 6th on the outside. And then let's see, for the c, we're looking at 7 into 9. 7 goes into 9 once. You multiply and subtract, so 1 comes out, 2 stays in, so c to the 1st comes out. And let's see what all is left in. We have a 3, no a's, 1 b, and 2 c's. So that would be the simplified version of the radical.